Hello, welcome back to the second part of chapter 10 for Chem 2b, and today we're mainly going to be talking about just Gibbs free energy. And the internet definition of Gibbs free energy is the amount of work in a system that can't the amount of energy in a system that can't be used to do work at constant pressure and constant temperature, just like everything in this class, always at constant pressure and constant temperature, which, if you remember, is 25 degrees Celsius and 1 atm. But you don't have to entirely memorize the dictionary definition of Gibbs free energy, but what you should know is that a lot of the time in this class, when you use Gibbs free energy, it's probably just going to be to define spontaneity, because people or chemists from hundreds of years ago saw it as an easier way to figure out spontaneity instead of calculating the entropy of a system and the entire universe. And one thing to note is that when the change of the delta G, that's what I'm just going to call it, the change in delta in Gibbs free energy, when it's less than 0, it means that the reaction is spontaneous. And when it's greater than 0, it means that the reaction is non-spontaneous. Then you're probably thinking, what if it's equal to 0? When delta G is equal to 0, we call that equilibrium, which is a common term that you've probably used in another chem class. The formula for this Gibbs free energy, it encompasses the other state functions. If you remember what state functions are, you can look it up if you don't remember. It involves enthalpy and entropy, which was just the video before, and temperature as well. It's just equal to the change in enthalpy minus the change in entropy times the temperature, which is also still used in Kelvin. With the help of this equation, we can easily tell when, well, not easily, but we can predict how to tell when a reaction is spontaneous or non-spontaneous. And if you remember from this equation above, when G is less than 0, so when it's negative, it's spontaneous, and when G is greater than 0, so when it's positive, it's non-spontaneous. And I'll show you how to know when it's spontaneous or non-spontaneous algebraically using this formula right here. You've probably seen something similar to this if you watch the lectures in Chem, but this key gives you how to know when it's spontaneous at certain conditions, spontaneous, and it can never be spontaneous. So instead of memorizing this, you can do this in a way by using a kind of Punnett square, a chart. So at the top of the chart, it's going to be when delta H, it's all about delta H when delta H is negative and when delta H is positive. And on the side here, it's going to be when entropy is negative and when entropy is positive. And then you write out the equation on the side here where G is equal to change in H minus delta S. Okay. When you think about it like this, when delta H is negative, it means this part is negative. And when the entropy is when the delta S is also negative, this part is negative. Now imagine this. A negative, the minus sign here changes this. It makes the S positive now. So it's going to be a negative minus a potential positive. So that means when the temperature goes up, the likelihood of this being positive also goes up as well, which is why this is going to be spontaneous at low temperatures. It can be spontaneous, but only at low temperatures. Because once again, I'll do it again algebraically. If these two are negative, that means with this negative sign here affecting the delta S, that means this part is going to be positive. So that means the more you increase the temperature, the more positive the delta G is going to get, which makes it less spontaneous. And when the temperature is lower, then this part is going to be lower as well, which makes it more spontaneous at lower temperatures. So the lower it goes, it means this side is lowering as well, and this side is already negative, so it doesn't affect it. Now we're going to move on to when the delta H is positive. So that means this side is positive, and then the entropy is negative. And since this negative sign, like this one, is also affecting how this whole thing moves, that means it's going to switch the signs. So it's going to make this side positive at all times. And when you notice, when the delta H and the entropy, when they're both positive, there's no effect that the temperature can have, since the temperature doesn't change size. It's always going to be positive. So that means at every single temperature, the delta H is always going to be positive. And remember, when it's positive, it means it's non-spontaneous. So that means at every temperature, this is going to be non-spontaneous. The temperature doesn't matter, because it's always going to be positive. And now we move on to this square, where the delta H is negative again, and the entropy now is positive. And once again, like every other one, since the negative sign is in front of it, it changes the sign, so it makes this negative. And when you look at it, since both of these are negative, this is negative, this is going to be negative as well, the delta G is always going to be a negative, because this is always going to be negative. If delta H, if it says it's negative, it's going to be negative. And if it says the entropy is positive, that means it's going to be a negative. So since they're both negative, the temperature increasing or decreasing doesn't change this. It's still going to be a negative number, probably a large negative number if it increases, and a lower negative number if it decreases. But the negative is still going to be there. So this row is going to be always spontaneous. And now we get to the last one, where delta H is positive and delta S is positive as well. Remember, the negative sign changes this to a negative, so that means the delta S part is negative. And since this is positive, while this is negative, that means you're going to be subtracting this portion from the delta H. And when you think about it temperature-wise, what temperatures is going to make the delta G on this side negative? The temperatures that are going to make it negative is if this increases. If the negative part of the equation keeps increasing, then this side is going to be negative. So that means as the temperature increases, it's going to be spontaneous over here. So spontaneous at higher temperatures. And the math behind it is, so let me use real numbers, so it's maybe it might help you understand more. For the change in enthalpy, let's say this is a positive 5, and the change in S is also a negative 5. If 5 minus 5, it gives you 0. But let's say you're multiplying this part, which is by the temperature. Let's say the temperature is like 2 or something. When you multiply it by 2, it's going to be 5 minus 10 instead of 5. But then if you multiply it by 0.5 instead of the temperature, right over here, the temperature is 0.5 instead. 0.5 times 5 is less than 5. So it's going to be 5 minus a number which is less than 5. Probably about, let me guess, I'm not sure if this is right. It's going to be positive versus this is going to be negative. So if you lower the temperature, it's going to make it positive, which is not spontaneous. But if you increase the temperature, it's going to make it negative and more spontaneous. So this is a way to understand something like this. And if asked on a test, you can derive this on your own. If you do it mathematically, you write it out mathematically. Or you can just look at this table and you memorize that the side that's always spontaneous and the side that's non-spontaneous are diagonal to each other, and then low to high. If you write it like this. Now I'm going to do a problem that encompasses basically everything I talked about, the Gibbs free energy. earlier. So in this problem, for the reaction at 298 Kelvin, the H is right here, and the delta S is right here as well. And we're looking for the first question is asking for the delta G. And if you remember the formula, delta G is equal to change in enthalpy minus temperature times the change in entropy. So to do this problem, it's an easy one. We just plug it in to find delta G. And they've given us the values, but right here, if you notice, this value is given in kilojoules and this one's given in just joules. So we have to decide which unit we want to use. And to make this easier, I'd rather use joules because it's multiply. I'd rather multiply by 1,000 than divide by 1,000. So we're going to multiply this out by 1,000, and it gives us negative 393,500 joules minus the temperature is 298. We don't have to transfer it to Kelvin because it's already given in Kelvin. So 298 Kelvin times negative 213.7 joules per Kelvin. And the Kelvin cancels out. We're left with just joules. Now we plug this into the calculator and try to find the answer. And the answer is going to be 457,182.6 joules. And it doesn't ask to transfer it to kilojoules, so we can leave our answer like that. And then move on to number 2. So it says, assuming delta H and delta S do not depend on temperature, at what temperature is this equal to 0? So what we do here is we set this value equal to 0. Sorry about that. And by doing that, 0 equals to delta H minus T times delta S. You move delta H to the other side, and when you do that, you minus it. So, and we can get rid of the negative since it's on both sides. And then it becomes delta H equals to T this. And we're just trying to find T, so we isolate T by dividing this from both sides. And T is equal to this over this. And now we solve for T by plugging it in once again. The delta H is negative 393,500 joules over. And we plug this into the calculator again. After plugging it into the calculator, we get 1,841 Kelvin, and that's for the temperature. And you can do this units in either kilojoules or joules, but as long as they're both the same unit, then you'd still get the right answer anyways. And one thing that I did notice up here is that we plugged it into the calculator wrong, because we should be getting a negative, not a positive, and I replugged it into the calculator and I got a negative number instead, which looks about right, joules as well. And now the final question, the third question is the delta G negative below or above this temperature? So there are two different ways of doing this problem. We can do this the fast way by using what we know, where delta G is negative, so it's spontaneous. And if we use this equation again, this number is going to be negative if this one's negative and this one's positive. So it's going to be negative if delta H is negative and this is positive. And if you look at our numbers, they're both negative. So that doesn't work. So if they're both negative, if delta H is negative and if delta S is negative, that tells me that this is going to be negative and then this is positive. That means this coefficient, this part of the equation, is going to be negative. It's going to be, no, this is positive, so it's going to be positive. And if we decrease the positive, then this side is also going to be negative as well. If we increase the positive, that side is going to be positive. So we know that the delta G is going to be negative if we decrease the positive, and we can decrease the positive by decreasing the temperature. So it's going to be negative at lower temperatures. So we can answer this question quickly with that knowledge and say that the Gibbs free energy is going to be negative below the temperature. Below this temp. And another way that we can find this out and be 100% sure is literally plug it in. Since you got a calculator in the text, you can check your answer. So if you go back to this initial equation right here, instead of 298, just plug in the something below this temperature. Let's say 1800 times this. I don't know, I keep doing that. Times this. 7 joules. And then also plug in, you don't even have to do this part either, but to be 100% sure, since you can literally do the math, plug in a bigger number than that. Plug it into the calculator and see what you get. These are the numbers I got when I plugged it into the calculator. And as you can see, as we predicted, when you pick a lower temperature, it's going to be negative, and when you pick a higher temperature, it's going to be positive. This might take you a little bit of time, but I did it when I tested just to be sure, because this is one of the questions where you can kind of be almost 100% sure that you get it right before you move on.